Well, hello YouTubers, scrappers, anyone with an interest in chemistry, welcome back to my channel. Okay, so this is a continuation of the video I just released, well, this morning, on part 3 of my trying to make nitric acid from my own waste products. Some of the waste products are over here in these bottles, mostly copper nitrate, but other mixed nitrates too. So at the end of the last video, I had put some water and some sulfuric acid into the boiling flask here, the big 2-liter boiling flask, to try and dissolve the big slug of blackish copper oxide out of the bottom of the flask that was left after the reaction. It's been a couple days later. We've had some bad weather. The temperature has dropped precipitously. This has been sitting out here. And look what we've got. We've got a whole bunch of copper sulfate crystals in the bottom of this boiling flask. So that's great because I have use for copper sulfate. I can use that as an electrolyte in my electrolytic copper refining cell. So what I think I will do is I will pour off this liquid and redissolve those crystals in some distilled water, and then pour that off into a container and allow it to recrystallize. And then I should have some pretty pure copper sulfate crystals, I think. So I will get on with that later today. And in the back of the fume hood over here, in that flask there, we have the high-strength nitric acid we made in that last video. And I want to try and figure out what its actual strength is. So we'll work on that a little bit today and maybe answer a few viewer questions while I'm at it. So let me get started. Okay, we're going to get started with this here in a minute. Before I do though, there was one issue I'd like to point out from the last video. Some people may not have noticed it, especially if they weren't watching closely. But I wanted to talk about the importance of wearing your PPE at all times when you are working with this sort of apparatus trying to distill off nitric acid. You know, even if you're close to it, make sure you got your gloves on, okay? Because there was at one point, I actually grabbed the hose that was coming out of the condenser and into the suckback preventer flask that was over here. And I immediately noticed that that hose was wet. It was sweating something. It had a wet, oily liquid on it. And I'll show you a clip from that last video. Every time I think it's done, we get some more nitric acid coming over. I'm starting to think that the hose has been damaged here. Yeah, the hose is sweating something. I don't have my gloves on. It's oily. Okay. So this is silicone hose. I don't know what it is sweating. I don't know what the nitrogen dioxide gas is doing to it. Okay, yeah, there was a wet, oily liquid on that hose. I immediately went and washed my hands, but it's not really showing up. The lighting's not great, and it's been a couple of days, but I have nitric acid stains across these 3 fingers and the thumb. That hose was sweating nitric acid and nitric oxide, and I grabbed it without my gloves on. So yeah, always wear your PPE because something unexpected can be happening. I wasn't expecting that hose to be sweating nitric acid, okay, but it was. So yeah, you've always got to expect the unexpected. Nobody ever expects the Spanish Inquisition. Extra credit if you know where that came from. Alright, so let me get my PPE on here. Alright. I could probably wear my nitrile gloves for this, but you know, I just grabbed the vinyl ones. So I'm going to pour off this liquid. I will dump this liquid in my waste bucket, and this copper, whatever copper is left in here, will cement out on the iron in the waste bucket. Okay, but now we've got all these lovely crystals in here, and what I think I'm going to do is I'm going to redissolve them. My stir bar is down in there somewhere too. Oh, there it is. I'm going to redissolve them, and yeah, we got a little something else down there besides copper sulfate. But I'm going to redissolve them to get them out of the flask. So I want to put some distilled water in here. I'm just going to put in just enough to cover up the crystals, because I want to recrystallize these later. So I don't want to put a lot of water in there. And I'm going to turn the heat on, and we'll warm this stuff up and see if we can get those crystals to go into solution. And once they start breaking up a little, I'll turn the stir bar on and get some stirring going. Actually, I guess I can turn the stir bar on now, and it'll start stirring once that stuff breaks up. Okay, so let me dump this stuff in my waste bucket while we're waiting on this, and then we'll get to work on something else. Okay, while we're waiting on that stuff to redissolve, let's work on trying to figure out how strong the acid was we made. So, let's come over here to the fume hood. I'm going to do this in the fume hood for two reasons. Number one, it's fuming nitric acid. So I don't want to breathe those fumes. And number two, it's windy out here, and the scale does not behave well in the wind. So, the first step in trying to figure out how strong this nitric acid is weighing a known volume of it. So, got my graduated cylinder here. Now, I weighed the cylinder earlier and wrote the weight of it on the cylinder. Whoops! This cylinder has three little feet. Yeah. Let me zero it out. Okay. We turn on the fume hood. I'm going to close this door so we get some draw through the fume hood. This fuming nitric acid really lives up to its name when you pour it. It likes to fume. Okay. So we didn't make quite as much as I thought. I'm not going to stick my head in there and read it, so we'll just weigh it and see what we've got here. 48.41 grams. 48.41 grams. Okay. And how much do we have? Down here where I can see it actually. We have 34 milliliters, so not as much as I thought we made, and it has a slight blue-green tinge to it. I knew it was contaminated with some copper compounds. So, yeah, 34 milliliters. Call it 48.4 grams. Okay, 48.4. Alright, now we do a little math. Oh, and one more step before we get to the math. We need to know what the temperature of this stuff is at the time we're measuring it. 20.5 C. Okay, it's only been a few minutes, but I thought I'd give you a look at that before we get started on calculating the nitric acid density. The crystals are starting to dissolve. Spinning has started. Yeah, there's some looking like, yeah, so not all the crystals have dissolved yet. It looks like there might be some insoluble crud there. I may filter that before I let it recrystallize, just to get that insoluble stuff out of there. Then we should have good, clean copper sulfate crystals for use in my copper refining cell. Okay, now that we have all of the data we need to know to figure out the concentration of the nitric acid we made, there's a couple different ways we can do it. We can do it with titration, which I'm not really set up for, or we can do it with the density method. So there's tables online of nitric acid density versus concentration, and this is one of them. This is at handymath.com, and they have a table here where you can, of density and temperature, and that'll tell you what the concentration is. But they also have a calculator right at the top of the page, and the calculator makes life easy. So we'll just use the handy dandy calculator here, and that makes life easy. So we'll put in our numbers. It was 20.5 for the temperature, and density I can calculate really quickly. on my smartphone calculator app. So we had 48.4 grams of nitric acid divided by 34 milliliters equals 1.424. We'll call it 1.424. We'll just round up that last digit. So if I put in 1.424 and do calculate, look at that, 72.74. I hope you can see that. 72.74% concentration by weight. Okay, I was thinking it might be a little stronger than the azeotrope at 68% based on how active it was, because that was some really active stuff, both when I put it on the copper strip and when I put it a little bit on the nitro glove. It's possible, it's not that much stronger than the azeotrope, but it's possible that because it has so much nitrogen dioxide dissolved in it, and it's a really strong fuming nitric acid because of all the nitrogen dioxide, it might be a little more active. So that's a possibility. But yeah, hey, we did a little better than the azeotrope, and if I had switched the receivers out just like a couple minutes later, I would have got even stronger acid, I'm sure. I'm sure there was still a lot of water coming through at the beginning when I first switched them out. I was thinking I did it a little early. But, you know, it's so hard to tell exactly when the best time is to switch them out. But, yeah, that is not bad. That is really not bad at all. So we made some pretty darn strong acid using a waste product. So this is great. I've kind of got, you know, the circular recycling thing going. You know, I use nitric acid to get the gold and silver out of the IC chips, and then with the waste products produced, I can make more nitric acid, which I can use to get more gold and silver out of the IC chips. It's a beautiful thing. So I'm reducing my waste stream and reducing my costs. So that's great. It's wonderful. Okay. I'm a very happy camper right now. So yeah, there it is, the fume hood hanging out, still fuming. I need to put it back in a bottle. Let's see, I put the, I guess I'll put it back in that bottle. Although it'd be better in a bottle that was dark, but I put the weaker acid in the dark bottle back there that we made, just because it was empty. But you can see the blue-green color that the acid has. So it's not pure enough for me to use when I'm refining gold. I'll probably still either use my store-bought nitric acid for that, or I could redistill this stuff. I could set up the still and redistill it and get it good and clean and use it then. But I think I'll just use my store-bought acid for actually refining the gold I get out of the IC chips, and use this acid to actually get the gold and silver out of the IC chips. Okay, so yeah. And I'll need a lot less store-bought acid that way. So that's good. That'll keep my costs down and reduce my waste stream. So, perfect. So I will probably in the future set up and do a couple more runs to accumulate more nitric acid. And I may just store it in one of my old store-bought acid bottles. Because right now I've got acid from the last 2 runs stored. I got it stored in a round bottom flask in the back of the fume hood back there from the first run. I've got it in my brown bottle there, and I'll have it in here. So I'm running out of airtight containers to store the acid in, so I'll probably just get one of my old store-bought nitric acid containers and use it to store the stuff in the future. I'll just relabel it and say, you know, Mike's homemade acid, impure, danger, whatever. So, yeah. Okay, so not as strong as I thought, but still very useful for what I needed to do. It attacks copper, it dissolves it, that's what I needed to do. Okay. So I think it's time to talk about a few other things. Okay, so here's a look at my YouTube channel. And I'll tell you what, the nitric acid recovery videos have been very, very popular. Very popular. I mean, look at this. The first one I put out 7 days ago, 2,000 views. Second one 5 days ago, 1.8 thousand views. The third one I put out just this morning, 2 hours ago, 129 views already. And comments. Oh my goodness, have they generated the comments? And I appreciate it. I really appreciate the comments and the suggestions. Yes, and the questions. Yes, I appreciate it. I encourage it. Thanks a lot. Good ideas. Every single video that I have put out so far in this series has generated good suggestions and good ideas. Lots of help. It's like I'm crowdsourcing this. You guys just jump in and give me good ideas to fix the problems I've run into. I mean, somebody today has already said I should be using Viton tubing to fix the problem I had with the silicone tubing. And I'd already done some research. Yesterday was a rainy day. I had a lot of time on my hands, so I was doing some research, and it looks like PVC tubing also stands up to nitric acid, nitric oxide very well. So I've got some PVC tubing. I'll give that a try next time. We'll see how it goes. If that falls apart or gives me trouble, I'll try the Viton tubing. But yeah, all kinds of good suggestions, good ideas, good feedback, and lots of questions. Okay, and yeah, already only 129 views already. And already I'm getting more about, oh, why aren't you doing it the way Nerd Rage did it? I haven't watched all of Nerd Rage's videos. You know, I'm busy making my own videos. I'm not watching everybody else's, and I'm not trying to copy anybody. You know, I get a lot of comments. Why aren't you doing it the Nerd Rage way? Why aren't you doing it the Nile Red way? And I'm like, I don't really know how they're doing it, you know, because I haven't seen all their videos. And, you know, I have a lot of fun just trying to figure it out for myself too. I mean, you know, if I just want a recipe to follow, yeah, I will go watch their videos, take notes, and say, okay, this is the way it works. But you guys don't want to see that. You don't want to see me copying Nerd Rage. Go watch Nerd Rage. He does it better. You guys don't want to see me copying Nile Red. Go watch Nile Red. He does it better. You know, I'm trying to figure it out kind of on my own from first principles here. And yeah, so I appreciate the feedback, though. I did go watch one of Nerd Rage's videos, you know, after all the dozens of people told me I needed to, and I got the idea of using the, pardon my arm, the Teflon tape on the ground glass joints, and that worked great. So yeah, Nerd Rage has got some good ideas, some good information in his videos. I just don't have time to sit around and watch him all day. I'm busy experimenting and doing my own thing. And I'm probably going to get some feedback about how I measured the concentration of my nitric acid using the oh, I already shut down that website, using the density method. They're probably going to tell me how inaccurate it is, and yeah, probably it is, but I'm only looking for a ballpark figure. I'm not really set up for titration. I am not, you know, a professional chemist. I'm not even a halfway decent amateur chemist. I'm an electronic engineer who got into chemistry out of necessity to refine the gold I get from scrapping out electronics. So yeah, I know just enough chemistry to be dangerous and do what I need to do, okay, and not a lot else. So that's why I do the things the way I do them. But yeah, anyway, I really do appreciate the feedback. I appreciate the suggestions, the questions. Keep them coming. I'll try to answer them as best I can. I may have a dedicated Q&A video again in the future. Oh, the donkey next door is losing his mind again. That happens about a dozen times a day. So we may have a dedicated Q&A video again in the future, because I do get a lot of questions asked over and over again. But I think that's enough for this video. Let me get back to doing something useful. And I think what I'm going to do is, I've turned the heat way down on this. In fact, let me turn it off now and let it cool down some, but hopefully not enough to start crystallizing. And then I will filter this, and we'll see if we can crystallize out some really pure copper sulfate out of it. Okay, before I set up to filter that copper sulfate solution, let me get this stuff bottled back up before I do something stupid like knock the graduated cylinder over and spill it all over the inside of the fume hood. Want that. Come on, good to the last drop, like the coffee. There we go. Okay. Now that that's safely out of the way, I'll wash that graduated cylinder later. Let me set up to filter that stuff over there. Okay, let me get this stuff filtered, pump turned on. Never a good idea to filter a hot liquid, but this has had a chance to cool a little bit. I want to get it filtered before it has a chance to cool down enough to start recrystallizing. I want to get that crud out of it, whatever it is. And I'm using a glass filter here with backed up with a paper filter. So even if the paper filter does soften up in the heat, it's not going anywhere. It's not like we're going to have a blow through like we might have with a Buckner funnel. So yeah, there's definitely some insoluble crud in there I want to get out. And then we should crystallize out some really nice copper sulfate crystals. Now, speaking of sulfates, another thing that a lot of people are telling me, well, again, I need to go see Nerd Rage's video apparently. I guess I'm going to be watching a lot of Nerd Rage's videos in the future. That, you know, in my small scale test I used sulfuric acid and liberated the nitric acid from the copper sulfate salt, oh, there's my stir bar. In my small scale test I used sulfuric acid and liberated the nitric acid from the copper nitrate salts with some heat. And people are telling me that's a better way, I should get a better yield, and they're probably right, because I was basically relying on thermal composition of the copper nitrate, which produces a lot of nitrogen dioxide gas, but not really all that much nitric acid. So in the future, we may try that. I mean, sulfuric acid is cheap. It's not very expensive. So I could easily add some sulfuric acid into the mix. Not a problem. Wow, look at that pretty blue fluid down there. I'm going to get some nice copper sulfate crystals out of that once it cools down some. I'll get that transferred to another vessel, and we'll let that crystallize. But yeah, I'm thinking in the future I may use some sulfuric acid in here and do it that way. I might get a better yield, you know, more nitric acid, less nitric oxide, which is fine with me. And the expense won't be that much more, just a little bit more sulfuric acid, which, you know, the sulfuric acid drain opener at the grocery store is not that expensive at all. So yeah, I may go that way. And speaking of expense, how much did it cost me to make, well, this little bit of nitric acid here? I mean, this is the more concentrated stuff. I've got a whole lot more of the less concentrated stuff too. So how much did it cost? Because somebody's going to bring that up, I'm sure. It's always about the money. Well, it cost me 2 bags of ice from the Quickie Mart to cool everything down. That's basically what it cost me. Okay? I had everything else already. So, yeah. Yeah, if you're starting from scratch, you gotta buy, you know, all the whole, you know, the hot plate, stir plate, the condenser, all of it, the boiling flask, the receiving flask, the sidearm flask. You gotta buy all that if you're starting from scratch. But, you know, I had all that, so, you know, it didn't really cost me anything. I had the starting material, which I still have a ton of, so I could make more. I may do another video in the future with the use of sulfuric acid and see how that comes out. But that may be a few weeks down the road because I got other stuff going on. But anyway, yeah. Turn the pump off. Well, actually, yeah, let me turn the pump off. I'll clean out this funnel later. I don't want to add a lot of liquid to this flask because I want this stuff to crystallize, not stay in solution. So it may be a few weeks, month or more before I do another nitric acid video. But I think I definitely want to try it using sulfuric acid rather than just decomposing the copper nitrate thermally. Well, anyway, there we go. Nitric acid and copper sulfate from waste products. Okay, I hope you found this video interesting, entertaining, educational, inspirational, killed some time, better than what your boss tells you you're supposed to be doing, whatever. Give it a thumbs up, give it a like, subscribe to see future videos. Check out my second channel, Electric Geek 64. Got good stuff going on there too. Subscribe there, please. Help that channel grow. And we'll see you in future videos. Have a good one. Bye. So check this out. I put that copper sulfate solution that I filtered into the fridge for a little while, and look what happened. We've grown a bunch of crystals in it. Wow. Let me get the condensate off of it so you can see them. Cool. So I think I'm going to do is I'm going to pour this liquid off and save the crystals and maybe evaporate the liquid down and see if I can grow some more crystals. This should be some really pure copper sulfate. It's been recrystallized with distilled water. The liquid was filtered before I started crystallizing it, so this should be some really pure copper sulfate. Not that I really need it that pure for my copper refining cell, but still, you know, it's good practice to get pure reagents if you can. And here we are after pouring the liquid off. Aren't they pretty? Yeah, so I'll find a container to put these in, and I will evaporate down this liquid and see if we can grow some more copper sulfate crystals out of it. Cool. My second useful product created from my waste material. I'm loving it. Alright, well, thanks for watching. There's your post-credit content. I hope you enjoyed it. See you in the next video. Bye.